In this video, we are taking up some covalent bonding practice. So in this chart, in your version, it says carbon tetrachloride. I changed it in the past because I wanted my students to do something different because you've done a lot of tetrachloride, but bromide is in the same column as chloride. So you'd end up with a similar structure because bromine has 7 valence electrons, just like chlorine. So your overall structure would look similar, and the chemical formula would be similar. For carbon tetrachloride, you would have CCl4 as well. And we've done that several times together. So let's skip to the next one. You are given carbon and sulfur over here, CS2. So when I look at that, I look at the periodic table and I know I have carbon, which is a nonmetal, and sulfur, that's a nonmetal, and that's how I know this is going to be covalent. What I know is that carbon, there's one of them, and so for the name, because it's the first one, I don't have to say mono, I just say carbon. And then the second element, which is my nonmetal, I see there's 2 of them. So I have di, and I know it's sulfur, so I say sulf, and I know I end with ide, so it's ide at the end. So this CS2 is carbon disulfide. And if you look at my diagram here, I know from the formula that I have 1 carbon, and then I have 2 sulfurs. So I put my sulfur on either side of my carbon. I know carbon has 4 valence electrons, and I know each carbon has 6 valence electrons. Carbon needs 4 more overall, and each sulfur needs 2 more overall. So what we can do here is carbon can share 2 of its valence electrons with sulfur, and sulfur will share 2 back to carbon. And we'll do that with both sulfurs. So that means in carbon's little circle here, we see 1, 2, 3, 4, 5, 6, 7, 8. And in sulfur's little circle here, we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Everybody's stable, everybody's happy. And so our diagram, if you wanted to draw it with the bonds, the lines as bonds, we have a double bond between carbon and sulfur and another double bond between carbon and sulfur. Our next one is SiF4. Silicon is on the periodic table and it's a nonmetal, and fluorine is a nonmetal. It's all the way in column 7. So I know because these are 2 nonmetals that this is covalent bonding. I know I have 1 silicon, and because it's my first one, I don't have to say mono. So all the way over here, I say silicon. And then because I have 4 fluorine, I know this prefix for 4 is tetra. So I have tetra, fluor, and then ide at the end. So SiF4 is silicon tetrafluoride. My diagram here shows silicon in the middle with its 4 valence electrons, and each fluorine only needs 1 more. So we share 1 of sulfurs with this fluorine, while this fluorine shares with sulfur. We do that for all 4. So you might want to pause the video to double check if you did a diagram that it is correct. And our last one is N2, and we know N2 is one of those Hofbrinkel gases, diatomic molecules. It's 2 nitrogen bonded together. So this one is a little more tricky. We know, first of all, it's called nitrogen gas. And then when I draw my diagram, I have 2 nitrogens, and each of those nitrogens has 5 valence electrons because it is in the 5th column. But because it has 5, I know it needs 3 more to become stable. And because I know there's only 2 nitrogens, because the formula is N2, that I have to share 3 of one nitrogens with 3 of the other nitrogens. So this is called a triple bond. So these lines show each a pair of shared electrons. So we have 3 pairs of shared electrons here. And in this nitrogen circle, there's 1, 2, 3, 4, 5, 6, 7, 8. And in this nitrogen circle, we have 1, 2, 3, 4, 5, 6, 7, 8. Everybody's stable, everybody's happy. So for this, we were asked to draw the compound and state the chemical formula. So the first one is carbon tetrafluoride. So I drew a diagram so I could check my work. And I have, by the name, I have carbon, and that's only 1 of them, so that would make C. I have tetra, so I know whatever comes next is there's going to be 4 of, and it says fluor, so I know that's fluorine. So F, and there's 4 of them. So this is CF4, and when I drew my diagram to confirm it, to check, then I knew I was correct because it all worked. Silicon dioxide. So silicon dioxide, silicon, the first nonmetal here, doesn't have a little prefix, so that means I know there's only 1, and it's Si. I see di in front of the next non-metal. And then I see ox, so I know it's oxygen. So I say O, and I know it's di, so there are 2 oxygen in the molecular compound or covalent compound silicon dioxide. I drew a diagram as rough work to see if I was correct. And so I had 1 silicon in the middle and the 2 oxygens on the other side. And when I tested to see if they had the right number of valence electrons, now oxygen has 1, 2, 3, 4, 5, 6, 7, 8. This oxygen has 1, 2, 3, 4, 5, 6, 7, 8. And then the silicon in the middle has 1, 2, 3, 4, 5, 6, 7, 8. For chlorine gas, we know that that's one of our Hofbrinkel gases. And so each chlorine has 7. And so when I share 1 electron with this chlorine and 1 electron with this chlorine, they become stable. And because it's one of those Hofbrinkel gases, I know chlorine gas is Cl2. Hydrogen gas is also one of the Hofbrinkel gases, so I know that should be H2. I draw my diagram to check. Each hydrogen has 1 valence electron, and they share that with the other hydrogen. So that diagram confirms that the formula can be H2. Given the chemical formula, state the name. So CO2, carbon, there's only 1 carbon, so I can just say carbon. Oxygen, there's 2 of them, so I know there's di, and oxygen is ox, and I end with ide. So this is carbon dioxide. OF2, O is oxygen. F2, so I've got fluorine, and I have 2 of them, so that's di, fluor, and I end in ide. And SiH, for, I know I have 1 silicon, so I just say silicon. I have 4 hydrogens, so I say tetrahydride. So I add hydri is the hydrogen, and I end with ide.